To do a bioassay on sea lice, it starts at the farm where we collect the lice off of the fish. Each fish is anesthetized with MS-222 and collected individually into a tank, and motile stages are collected off of each fish into a separate container. Once the lice motiles have been picked off of the fish is then returned to a recovery tank and put back into the pen. When all the lice have been collected into the containers, usually we try and pick 4 containers. They go into a cooler. Ice packs are added with air stones, 1 to keep the water cool and 2 to keep the lice alive on the transport. We also collect containers of seawater from each site, return it to the lab where it goes into an incubator with air stones. The seawater is also put into the incubator so that it's incubated at the same temperature as the lice overnight. The 24 hours in the incubator allows any residual effects of the MS-222 to be removed. So 24 hours before we're slated to do the bioassay, we have to make up our emamectin benzoate stock solution. This is accomplished by measuring 5 milligrams of emamectin benzoate powder and mixing that with 50 milliliters of propylene glycol. We measure out the powder on a very sensitive scale, and what we have is a small table that is independent of all of the other tables and covered with a granite countertop to minimize the vibrations that might affect the recording of the weight. Once we've got our 5 milligrams, we then add a little bit of propylene glycol to the glass watch glass, and using a glass stir rod, we then mix that up into a bit of a slurry. The idea here is to try and mix the emamectin benzoate as much as possible and get rid of little chunks to make sure that it dissolves completely. Once the slurry is made up, we can then pour it into a small storage container. This container, you'll notice, is dark in color because we know that emamectin benzoate is light sensitive. So the foil-covered container that you see is actually where we store the powder. So now we just rinse with the propylene glycol and get it all into that bottle. We rinse that slide until we can't see any more of the original slurry still on the watch glass. And once we've rinsed for a few seconds, then we'll just pour the rest of the 50 mils into the bottle. Once the mixture's been thoroughly stirred in the dark watch glass, we then label it with what it is, stock solution, and the date that it was made. And for our purposes, we just store it back into the incubator that we store the lice in, so our 8 or 10 degree incubator, and that's where it will sit for the whole 24 hours. So 24 hours after we've done our EMB prep, we're now ready to start our actual bioassay. So we start by labeling our trays, and generally right now we get a minimum of 3 replicates of each females, 3 replicates of males, plus 1 extra tray where we will collect the extra lice that we can use for sorting later. This will become clearer later in the video. So we lay out 6 petri dishes, glass petri dishes, and this will represent our control plus 5 test concentrations, whatever our 5 test concentrations are going to be. So when you see here, we've got 3 trays laid out, 1, 2, and 3, plus the extra. All of our work is done on a container of ice to keep the temperature of the water and of the lice somewhat cool. It can heat up pretty fast in our lab, so this allows us to help control the temperature that we're working at. And now we are set up and ready to start picking. We've got seawater from site in each of the 6 petri dishes. We've got our forceps and our scissors, and we fill each dish, and we can begin picking. So now what we basically do is empty out some of the water because these things are harder to catch when they're allowed to swim around. So now that we're ready to begin, we're starting off with our first sort. So each bioassay consists of 2 sorting events. The first sort, and then we wait for an hour, hour and a half, and then we do a second sort to make sure that the final 10 lice in each dish are healthy and viable. So the females tend to be a little bit easier to pick because they're larger animals. So we gently place our forceps underneath their abdomen or gonad section and just, without squeezing them, pick them gently off the side of the bowl and deposit them into the Petri dishes. And we don't stock the Petri dishes each dish at a time. We randomly put our lice in so that there's no bias towards which lice end up in each dish. We stack each dish about 12 to 14 lice per dish on the first sort. The females get their egg strings clipped off at this point. We don't want the egg strings hatching during the bioassay procedure. So this is fairly straightforward. We can still, now we're going to go in and look at males. So males are a little harder to pick. They've got much smaller abdomens, gonad ends. And we gently, again, have to pick them up gently, but without squeezing, pick them up and put them into a dish. So here again, we're looking at between 12 and 14 organisms per Petri dish. If we had the opportunity and we had enough, we would also collect pre-females if that became necessary. And quite often out here in BC, we only get males and females. We don't often get a lot of pre-adults. And if we get enough Caligus clemensi, we will also do a few trays of those as well if we can. So again, minimum 3 trays of each sex and an extra tray. So while the lice are resting for their first hour, hour and a half, this is the time that we prepare our dilutions. So we take our 2-liter beakers and we label them with our test concentrations. So this will be the control plus our 5 concentrations. We often start at these concentrations. We can go up to 1,000 parts per billion, and then we would knock out the bottom 31.3. So in the summertime, some of our seawater that comes in from site, sometimes it has plankton blooms. And when that's the case, I don't like to use that water for mixing up the dilution. So we'll do a pre-filter through a 50 micron screen just to get rid of the phytoplankton and the zooplankton. And here, as we're preparing our working solutions, so we're looking at our seawater measurement, and then we set that aside. We take out our EMB bottle, mix it really, really well. And here we're going to add 20 mils of that stock solution to 1,980 milliliters of seawater to make up 2 liters of our working solution. And from this working solution, we will then make our test dilutions. So rinsing is important, and keeping in mind that whatever stir stick you use in your EMB bottle doesn't get used for anything else. The stir stick in your working concentration gets used only in the working concentration. So we're very conscious of not adding EMB concentrations when you're working at such small dosages. So the next step after we make up our working solution is then we just run through and make up our test dilution. So the control is always going to be 500 mils of seawater, and working on down the line. And each one of these beakers is labeled with the individual concentrations. So once our concentrations have been mixed up and we have 0 through 500 or 0 through 1,000 or 0 through 1,500, depending on what our concentrations are, we're ready for the blinding procedure. And this is important because when we go to read them and do the analysis afterwards, we don't want to know what concentrations we're reading. So in this case, we have a blinding sheet that somebody who's independent of the whole procedure comes into the lab and randomly applies a sticker of A through F on each of the beakers and matches it to the concentration on the sheet. So we might find that A is 0, B is 500, etc. So he lines them all up again as A through F and then takes this sheet away, and we don't get to see it until the next day when we're doing analysis. So once all your concentrations are made up, we put them back into the incubator to keep cool. So now we've left the lice for about an hour, hour and a half, and now we're going to do our second sort. And this is where we try and get down to 10 or 11 in each dish that are strong lice. And on one side, I've got my tray that has the extras, which has gone through the same procedure as all the trays 1, 2, and 3. So in this case, we're sorting males. Males tend to be a little bit tricky to sort because they do move around a lot. So it becomes a skill of swirling the dish to try and get them all to settle so we can tell the strong ones from the weak ones. Anything that doesn't stick or remains upside down gets removed from the dish and brought up to that 10 or 11 good animals. The females, pretty much the same thing. Anything that is not sticking to the bottom of the dish gets removed. After we've got our dishes balanced out at 10 or 11 good animals, we then label it A through F. And once they're labeled, they go into the incubator. And we proceed to do that through all of the replicates, through all the males and all the females. So now we remove our dilutions from the fridge and we put them on the table, and each one of these is lined up A through F, and we now stir each one really, really well, each with its own glass stirring rod. And then we measure out a quantity of about 45 to 50 mils of each solution into these little Erlenmeyer flasks. And this allows us to get pretty close to the same amount of water into each Petri dish. So once we've done all 5 of them, we can then start to take the dishes out of the incubator, and then we can start the procedure of sorting down to our 10 strong lice that we're going to be treating in the Petri dishes. So now we are ready to do the treatments. So each dish is now sorted down to 10 strong animals. So what we're looking here is I empty the water out, and anything that isn't stuck comes off the dish. I count to make sure there's 10 animals in there. And sometimes one dish will come down to 9, another one might stay at 11. So amongst the 6 dishes, I'll balance out to make sure that there's 10 strong individuals in each dish. If I don't have enough, that's where my tray of extras comes in, because the extras have already been handled. We know the sorted ones have been handled the same way as these guys, so we know we can use those as extras. The males tend to be a little bit harder, again, because they tend to be a bit more motile, so we have to make sure that they're all stuck to the bottom before we empty out each individual dish. When we're done, the empty dishes are handed off to someone who will now treat them. And just like any other treatment, you go A into A, B into B, C into C. And I like to line up my dishes all the same way every time I do the bioassay, so that there's no confusion. And sometimes if you're not paying attention and you don't know if you did the right thing, at least you know that the dishes are all lined up the same. Chances are that you have lined up A to A, B to B, and C to C. The other thing we do once the dishes are full is mark down the time that we treated them, so that we are aware of that 24-hour window, and we know for the next day when we should come back and look at them. So again, 24 hours after we've treated them, we come back to do the analysis. And this is the part where we're looking to see how many survived the 24-hour treatment. So we take out the dishes one at a time, the one that was done the earliest, and we're looking at categorizing alive, weak, moribund, or dead. So when we're looking at the lice, we have a sheet that we've got for recording. So we've got a sheet that lets us know what life stage we're at, how many lice were in each dish, A, B, C, D, E, F, and how many are live, weak, moribund, and dead. So in this part, these are the males. So what we're looking at here is, generally what I do is I swirl the dish and see if anything's going to stick, get it to stick, and then anything that's not sticking, I usually want to turn upside down so that I know that it's not sticking to the bottom. And then I sort them into categories of weak and dead. And this can be done in a couple of different ways, either with the clock of dividing it into 4 and having each quadrant have live, weak, or dead, which when the lives are alive, they tend to move around in the quadrants, which makes it difficult. So basically what I do is I count how many are alive. I then go back and look at my upside down ones and determine which are moribund. And I'm looking for movement in any of the little legs or in the carapace. If there's no movement, nothing, it gets swished to the dead side. If it's got some movement, it gets separated into the moribund side. And then once I finish that, I can count how many of each category are in each dish. And we do this for all 6 dishes. So the females tend to be a little bit easier, of course, to analyze because they are bigger. Here again, we'll see that one of these is actually going to be a weak one. And a weak is one that still swims but doesn't attach to the side of the dish very well. They're a little harder to count sometimes because they do move around and don't stay where you put them. But here I'm sorting moribunds on one side. I'm giving it a little touch. If I see anything moving, it goes into the morbid side. If I don't see anything moving, I put it in the dead side. And this one that's swimming around upside down, I would categorize as weak. It still swims, but it's not able to attach to anything and stay attached. And the live, of course, usually they're scattered on the bottom of the dish, but if they're stuck and they don't move around, then you know how to categorize them. Okay, so now we're ready to do our analysis of the results. So I have a spreadsheet made out where I've got 3 tabs. The first tab is the original data. So in this tab, I put in what each of the different trays shows me, A through F, basically putting in what live did in week. The next tab is original data manipulated, where I then copy the data from the original to this sheet. I add in my concentrations now that I unblind them, copy them to the column that says EMB concentrations. I then sort each individual tray low to high, so I get 0 to the highest concentration. And if you look in the column that says live after 24 hours, that column will just have the addition of live and week, so anything that's alive after 24 hours. The third tab is what I would use for my probit analysis. So here, the white area is actually linked to the live after 24 hours on the previous page, and I will enter the data from probit. So now I open probit. I've made up a template already that has my bioassay concentrations in it. Number of organisms is 10. I have 3 replicates with 5 concentrations plus the control. So when I enter in the data, right away, the initial data is all put in, and then I have to add in my live data to the 24-hour column. So I've entered 2 columns and in the process of entering the third. And when I do probit analysis, this is what I get. I get my graph and I get my levels. I can then copy the graph, copy my LC50 concentrations back to my Excel spreadsheet, and that gives me my report.